So what makes Proxima b interesting is that it's an Earth-like planet orbiting the nearest star to the sun.
For the first time in human history, we're not just imagining what another Earth might look like. We're seeing it with our own eyes through the lens of the most powerful space telescope ever built, the James Webb Space Telescope. Scientists have just captured the clearest image yet of Proxima b, a planet orbiting the closest star to our own, Proxima Centauri. Just 4.2 light-years away, Proxima b has long been one of the most talked about exoplanets. It's nearly the same size as Earth and sits in the so-called habitable zone, where conditions could, in theory, allow liquid water to exist. Until now, Proxima b was only numbers: mass, distance, orbital speed. But today, for the very first time, it's an image. The light Webb captured didn't come from the planet reflecting sunlight. It came from the planet's own heat detected in the infrared. Proof that we're now looking at the world itself. Not just a point on a chart, not just a theory, but a real place. What does this image tell us? Could this be the first real glimpse of an alien world like our own? And if so, what else might be out there? This isn't just science. It's history in the making. The clearest view yet, a glimpse of another Earth. For the first time in history, we've seen it. Not imagined it, not simulated it, but truly seen it. A real image of an alien planet just over 4 light-years from Earth. The James Webb Space Telescope has just captured the clearest view we've ever had of Proxima b, a planet that orbits the closest star to our sun. This isn't just another space photo. This is something much bigger. For decades, astronomers have been searching for planets like ours, places that might have the right conditions for life. Proxima b has always been a strong candidate. It's close. It's almost the same size as Earth. And it orbits in the habitable zone where temperatures might allow liquid water. But until now, all we had were numbers. Data from telescopes showing how its gravity tugs on its star or how it dims the light during a pass. We could guess what it was like, but we couldn't see it. Then James Webb changed everything. Using its powerful infrared instruments, the telescope managed to block out the light from the star Proxima Centauri and focus on the tiny signal from the planet beside it. Over several weeks, it gathered enough data to build the clearest image ever of Proxima b. What it showed us was incredible. A world that isn't just a blurry dot anymore. We could make out signs of temperature differences, with one side likely always in daylight and the other in constant darkness. We could even tell that the planet isn't covered in thick clouds like Venus. Instead, it has a surface that reflects light in a way that suggests it's rocky, much like Earth. This image isn't just a scientific win. It's a moment that changes how we see the universe. Proxima b is no longer a mystery. It's a real place. It has light, shadow, heat, and maybe even more. We don't yet know if life is there, or if it ever was. But now, for the first time, we can look at that planet and say, we've seen it. Now let's zoom out and talk about the star that Proxima b orbits, Proxima Centauri. It's not just close, it's the closest star to our sun, part of a 3-star system called Alpha Centauri. While 2 of those stars are bright enough to see from Earth with the naked eye, Proxima Centauri is smaller, cooler, and dimmer. You can't see it without a telescope, but it's the one with the most interesting planet. Proxima b orbits very close to its star, much closer than Earth does to the Sun. In fact, it completes a full orbit in just 11.2 Earth days. But because the star is much cooler than the Sun, Proxima b still falls within what scientists call the habitable zone. That means it gets about the same amount of energy as Earth does. In theory, that could allow water to exist on the surface. And where there's water, there could be life. But it's not that simple. Proxima Centauri is a red dwarf star, and red dwarfs are known for being active. They give off powerful solar flares, bursts of radiation that can blast a planet's atmosphere. Proxima b gets hit with radiation hundreds of times stronger than what Earth receives from the Sun. If the planet doesn't have a strong magnetic field, or if it lacks a thick atmosphere, those flares could strip away its protection and make the surface unlivable. Still, Proxima b holds a special place in science. Because it's so close, we can study it better than almost any other exoplanet. And with each new observation, we learn more. We now know it's a rocky planet, not a gas giant. We know its size, its distance from its star. And now, thanks to James Webb, we even have a sense of what it looks like. It's a planet in a tough neighborhood, but it's also the best shot we have at finding another Earth in our cosmic backyard. And that's what makes Proxima b so fascinating. It's not perfect, but it's real. It's nearby, and it's possible. To see a planet like Proxima b hiding in the blinding light of its star, you need something extraordinary. That's where the James Webb Space Telescope comes in. Launched in 2021, JWST was designed to see things we've never seen before. Not just distant galaxies and newborn stars, but also nearby exoplanets like Proxima b. What makes it special is how it sees the universe. Unlike regular telescopes that capture visible light, Webb focuses on infrared light, heat that lets it see through dust, gas, and glare that usually hide planets from view. To image Proxima b, scientists use two of Webb's most advanced tools, NRCam and MIRI. These instruments don't take a single snapshot. Instead, they collect tiny amounts of light over days and weeks. The team then stacks all that data together to reveal what was hidden in the noise. In this case, that meant pulling the faint heat glow of Proxima b out from behind the much brighter light of its star. The result was a sharp contrast between the star and its planet. Enough to tell that the planet is real, rocky, and not just a shadow in space. But Webb didn't just snap a picture and call it a day. It studied the planet's brightness, how heat spreads across its surface, and how that heat changes over time. That's how scientists know the planet is likely tidally locked. One side always facing the star, the other in constant night. That changes everything. It means one side may be scorched while the other could be freezing. This kind of technology didn't exist just a few years ago. Webb's ability to look at the universe in this way is like upgrading from a blurry webcam to a high-definition camera. And with it, we've finally turned Proxima b from a ghost in the data into a visible world. This is more than a cool space tool. It's a key to seeing other planets, not as theories, but as places. Webb showed us that Proxima b is real and that we're ready to look even closer. So, what did the James Webb Telescope actually see when it looked at Proxima b? A lot more than just a dot of light. The image itself may not look like a photo from your phone. It's made from invisible infrared light, heat, not color. But when scientists process it, they use color filters to show the differences. Brighter areas mean warmer temperatures. Darker areas mean cooler ones. And from this, a story begins to unfold. First, the planet looks rocky. Its surface reflects light the way rock and dust would, not like a gas planet or a world covered in thick clouds. That's important. It means we're likely dealing with a solid surface, not a swirling atmosphere like Jupiter or Venus. Second, there's a clear temperature difference across the planet. One side is warmer, probably the side facing the star 24/7. The other side is darker and colder, always turned away. This kind of tidal locking happens when a planet is close to its star. It creates extreme environments, but it also means that in between those two sides, the twilight zone, temperatures might be more stable. Third, there's a small chance we're seeing signs of an atmosphere. Webb picked up hints that the heat on the planet doesn't vanish instantly, which could mean there's a thin layer of air holding it in. That's still up for debate, but it's a big deal. An atmosphere is key for supporting water, climate, and maybe even life. Finally, scientists are asking, is there any trace of something more? Could there be signs of heat from volcanoes or even lights on the night side like cities? JWST is powerful enough to detect faint glows if they exist. Right now, there's no proof of either, but the fact that we can even ask those questions shows how far we've come. This image isn't just a look at another planet. It's the closest thing we've ever had to standing on a distant world and looking around. Now that we've seen Proxima b, scientists are studying every pixel of light to figure out what kind of world it really is. First, the surface looks rocky. That might sound small, but it's huge. It means this is a planet with solid ground, possibly with mountains, valleys, or maybe even ancient riverbeds. It's not a gas giant or a cloud-shrouded world like Venus. Second, the brightness of the planet, the way it reflects heat, gives us clues about its texture. It's not smooth or shiny like ice. It absorbs and reflects heat like dry rock. This supports the idea that Proxima b might have a bare solid surface, maybe like Mars or a rocky desert on Earth. Third, some data from JWST hinted at a very thin atmosphere. It's not confirmed, but the way heat moves across the surface doesn't match a world with no air at all. A light atmosphere could help hold some warmth and protect the surface from sudden temperature swings. Fourth, there might be signs of internal activity, like volcanic heat. Some patterns in the thermal map suggest areas that are warmer than expected. That could mean the planet's core is still hot, which might also help maintain an atmosphere. Just like Earth's volcanoes release gases that replenish ours, every new piece of data builds a bigger picture. And while we still don't know if Proxima b is truly habitable, we now know it's not just a lifeless rock. It's dynamic, active, and full of mystery. Proxima b might be a planet in the right place, but it lives in a very rough part of space. First, its star, Proxima Centauri, is a red dwarf. These stars are small and cool, but they're also violent. They release sudden, powerful flares, huge bursts of radiation that can last for hours or even days. Proxima b gets hit by these far more often than Earth does. Second, these flares don't just light up the sky, they could destroy a planet's ability to support life. Without a strong magnetic field, the radiation could strip away any atmosphere. And without an atmosphere, water can't exist on the surface for long. Third, even if some atmosphere remains, it may only survive in one small zone. Because Proxima b is tidally locked, there's a chance the middle zone, where day and night meet, is safe enough for air and liquid water to exist. It's a narrow line, but maybe, just maybe, it's enough. Fourth, recent models show something hopeful. Proxima b had an ozone layer like Earth, it might survive. Ozone can block harmful UV radiation, and even on a flare-active planet, that might be enough to protect life, at least in small stable areas. So yes, Proxima b is under constant fire from its star, but it also might be hanging on, shielded, clinging to habitability in the twilight. Now here's where the story gets even more exciting. What if there's more to Proxima b than just rocks and heat? First, JWST is powerful enough to detect artificial light, like the glow from cities or mirrors in orbit. If there were a civilization there, using technology to brighten their night side, we might be able to see it. Second, one theory suggests that an advanced species could use massive mirrors to reflect sunlight from the day side onto the night side. This would balance the extreme conditions and make more of the planet livable. It's a wild idea, but with the sensitivity of JWST, it's not impossible to detect. Third, although we haven't seen anything that looks artificial, Proxima b is now one of the top targets for future SETI, search for extraterrestrial intelligence, missions. If intelligent life is nearby, this is where we'd want to listen first. Fourth, just knowing that we can look this closely at a world outside our solar system opens new doors. For the first time, we can seriously search for signs of technology, not just life in the dark. We're not just asking if Proxima b is alive. We're asking if someone might be living there. Seeing Proxima b like this changes everything. This isn't just a data point, it's a place. First, this is the closest potentially habitable planet we've ever seen, just over 4 light-years away. We now know it's rocky, possibly with a thin atmosphere, and has temperature differences across its surface. Second, it's become a symbol, a test case for how we search for life on other worlds. If we can study Proxima b this clearly, we can study other nearby planets too, like the ones in the TRAPPIST-1 system or orbiting stars like Tau Ceti. Third, it fuels our dreams of visiting one day. At our current speeds, it would take 75,000 years to reach Proxima b. But new ideas like solar sails powered by light could shorten that to just 20 years. Projects like Breakthrough Starshot are already working on it. Fourth, this image is a reminder of how far we've come and how far we still have to go. We used to wonder if there were other planets. Now we can see them. Maybe one day, we'll stand on one. Proxima b isn't just a planet anymore. It's our first real step toward another world and maybe, just maybe, another home. So now we ask, if Proxima b truly is another Earth, who or what could be living there? Let your imagination run wild. The universe is just getting started.